Right, g'day. It's Luke Beattie and Luke Checker here from GenZ Energy. And we're just going to start doing a series of videos around technology. Luke is one of our mechatronics engineers
Yep.
and one of the brains behind GenZ Energy, I would say.
Yeah, one of them.
One of the smarter brains anyway.
Oh, yeah, I wouldn't say that.
Yep.
Definitely a brain, but
Yep.
yeah.
So we thought we could pick up on some topical things that are happening in the storage space, obviously with the cheap home batteries program. That's it's a massive space at the moment.
Yep.
We also play in other spaces, but one of the things that I thought would be really interesting to kick off with is what was on my desk on Monday morning. So I came into the office and there's 3 mechatronics engineers here, and you're all young blokes and pretty passionate. And in their spare time, they'd built a sodium battery.
Yes, yeah, it was a sodium prototype battery unit. We've got it here in front of us. I must say, with that lead off, what we've got here is the sodium battery they left on Luke's desk. Now, admittedly, it looks, quite more impressive, we say in person. When it was on your desk, we did have a note saying, "We promise it's not a bomb."
Yeah. And I got to plug it in.
Yes,
too,
you did, yes.
As
And
the
it didn't explode.
least technical person in the team. I
Well,
thought
we
that
thought
was...
the first time here as your tenure, we thought the prototype would be started off by you. But yeah, so this is the unit that we've got in front of us. You can see all the sodium cells off to the left-hand side, left, your guys are right. And then we've got the BMS module sitting here.
So just to speak about this, what you guys have done over the weekend is you took these sodium ion cells, which are, if you've got an example there, so these are cylindrical cells?
They are indeed, yep. So very similar to the lithium ferrophosphate cell design, like same form factor, these are just slightly higher. Electrical capability of the cells is quite different, but that's just, again, as chemistry change, so do the electrical properties. But more importantly, the way these fit into a cell pack is exactly the same as the lithium cylindrical cells. So that means that all the infrastructure that we had here to make lithium packs, we could use it to make our first prototype
So in
sodium
theory,
pack.
you can just swap out the lithium ion phosphate cells with the sodium ion cells.
Straight for the sodium ion.
So why would you do that? What's the benefits of sodium ion cells?
So sodium ion cells is a bit different to lithium ferrophosphate. Well, lithium ferrophosphate is our bread and butter that we've been using for most of the time. And we like that chemistry because of its thermal stability, its capacity. Whilst it's not as good as the nickel manganese cobalt lithium varieties, it has a good bit of capacity behind it compared to energy density. What it does importantly though, compared to the sodium ion cells, is that it has a good amount of energy throughput versus its total density. Meanwhile, sodium ion cells, while they don't have that much on the energy density side of things, they're much more thermally stable. They're also a robust chemistry in terms of...
When you say thermally stable, that means that they're less likely to have thermal runaway.
Yes,
so
exactly,
from a safety point of view.
Yep. Yeah, as we know, one of the big concerns with lithium ion in general has been their thermal runaway. When you get into those extreme fault conditions, there is always a potential for that.
Which we've seen some, it's pretty rare, but some of the home fires caused by scooters, by all these devices that have lithium-based batteries. Very rarely home batteries.
Especially because the home batteries are normally those lithium ferrophosphate, those more stable chemistries. But the nickel manganese cobalts, those high energy throughput ones, they're the ones that seem to be causing some issues.
So you've got safety. What are the downfalls of sodium ion cells?
So I mentioned a bit previously, the downfall being is the energy density isn't quite there. Also, the chemistry is still rather new into the market. They don't have the large cell manufacturing base that lithium chemistries do. So there's been some reported problems with like salt longevity of the cells. They're not still doing like, the 10,000 cycles that we see from the lithium ferrophosphate designs. And then obviously the energy density. So you're going to have more batteries in terms of volume to get the same amount of capacity that you'd get out of a lithium ferrophosphate.
So what can we expect to see? So I expect that we're going to see this. I did see that cattle are going into commercial production of sodium ion cells, specifically for EVs, I think, and maybe safety was a driver for that.
Safety is the big
so
one.
Can we expect those other large battery manufacturers to also go towards sodium ion? The answer seems to be LFP and lithium-based, NMC, and then sodium ions additional for certain applications. How long till it would be a mature technology?
I think you've seen this like similar product lifestyle in terms of lithium chemistries. It's been almost 20 years now, and we're only just starting to see them come into the mainstream as a very popular thing for home energy. I think the sodium ion seems to be faster on the uptake. People aren't having to deal with the whole convincing people that they're safe. Sodium ion, it just inherently, when you say a sodium product, no one really seems to panic about it because we just think of salt. So the uptake's been quite quick. I would still say they're about like 5-10 years away from it being the full-blown beast that we've seen with lithium ferrophosphate designs. But that being said, early adopters, as you've said, cattle are already starting to go to production.
GenZ Energy as of the weekend.
We have one unit.
And where can viewers buy this unit?
Well,
a bit too early for that.
For a bespoke design, we can make you one a month, maybe. And
Fantastic.
we are limited to, 1P8S. So
Okay.
yeah, if you've got to use for a 24-volt, quite large pack with,
Yep.
3 amp hours of capacity,
Yep.
yeah, send us an email.
And just paired with this is our own proprietary BMS, which
Yeah.
that's one of the other things that GenZ Energy, for a range of our products, we've developed BMSs.
Yep.
So including the PCB design,
hmm
the ZDC platform, which
Yep.
is about monitoring and control.
Yep.
Just shows that in Australia, we are capable of leading the pack or being in the front runners
hmm
with some of this stuff. What's your forecast for sodium ion batteries and modules and systems in
Oh,
Australia?
in Australia. So I think as we see the home energy market continuing to diversify, sodium offers a cheap alternative there that I think could have a lot of impact into the market itself. One of the main drivers, again, whilst the energy density isn't there, the chemistry itself is quite inexpensive. So for, more scalable, low cost, affordable and safe power systems, I think you could see sodium being applied there.
Mhm.
It does have good energy throughput compared to density, so you can use these at high charge rates. So you could potentially see them in those kind of novel applications, the scooters you were mentioning
Mm.
before, the small scale power systems. There's definitely market for that there as well.
So higher charge rates now with lithium-based batteries,
Mhm.
if you're pushing high charge and discharge rates,
Yep.
that can degrade the battery over time?
Yeah, so there's been a lot of research on it in terms of the impacts of rapid charging. There's a company whose name escapes me off the top of my head, but experimenting with different charge profiles.
Mm.
But typically, yes, if done incorrectly, I should say,
Mm.
rapid charging can have a degrading effect on the capacity of the cells.
Mhm.
Meanwhile, the sodium chemistry just innately allows you to do 1C charges quite frequently, and then the 3C discharge is also quite appealing for the sodium chemistry.
Okay, so that's another use case there for
Yep.
certain applications where you need really high charge rates.
Yes, exactly. Yeah, yeah.
Yeah, cool.
Yeah.
Cool.
So that's probably the main one there. And then the other thing that sodium is great at is, again, the thermal stability. So when we start looking at some of the more fringe, mining applications and that, where we're starting to look at work, especially here in WA in the Pilbara and
Mm.
stuff, that is where the sodium cell could thrive quite well with the ability to handle those high temperatures.
Mhm.
Yeah.
Oh, that's good.
Yeah.
That's a good toy, good prototype. And we're interested to hear more from those who watch this video. Can reach out to us and update us with what you're doing with sodium ion cells, and watch this space. I mean, we're really busy with the development of lots of our products at the
Yep.
moment, and we've got CEC listed products coming through, which will be eligible for the cheap own batteries program.
Yep. Yep.
We've got a whole bunch of other ones that are top secret that we can't actually put out there publicly at the moment. But I think this is one that we're going to continue to develop and test
Yeah, of course.
and watch this space.
That is the plan. Yeah.